much. Good morning. For those who don't know me, my name is Zimmermann. I'm working for the European Commission. The name of my unit currently is Complex Systems and Advanced Computing. Who wonders what is complex systems? It's exactly what you think, those systems which are not simple. If you go to the internet, that's basically the definition. In that unit, we have more or less 3 strands, and one of them is manufacturing. The other 2 are complex systems and the computing part, the high-performance computing part. So, as I often put it, manufacturing, especially for me, as I'm a manufacturing engineer by training, is the first instantiation of information and communication technologies in the near future. Now, we have heard a lot about Horizon 2020 and the normal introduction to Horizon 2020. There are some elements in my speech. This is the outline for today. So, why ICT in manufacturing plays such a dominant role? What is our vision for that field in Horizon 2020 at the moment? The public-private partnership for factories of the future in Horizon 2020, and what is our current thinking in the innovation part of Horizon 2020. I will conclude. Let me just relate a little bit to the previous speaker. Yes, I also hope that this is the best framework program ever formulated. But speaking about innovation, manufacturing, and Horizon 2020, if I understood your figures right, then you're basically contributing 5% of the overall budget in Switzerland. Rule of thumb, which is quite big for a country like Switzerland. The point is also that if you really move so much to bottom up and in the direction of innovation, you have overall the difficulty, and I think maybe I shouldn't say that, but you have overall the difficulty that you easily come into the position where bureaucrats have to make choices. Now this is this grain of salt into that. We are going in that direction, undoubtedly too, but we should be careful that we come in quite dangerous zones if we do that. And that in the previous framework programs, there were all kinds of checks and balances which would avoid some of the loopholes which we might see in the near future. Now, why is research and development so important? You probably know this figure. You can see that countries which heavily invest in research and development have much stronger growth and cross-national power. It's the basic message of this, and you can see the situation of different countries on that. The Horizon 2020 is basically cut in 3 major parts, and that is societal challenges, industrial competitiveness, and excellence in science. Now we, from the ICT part, we basically say our strongest bit is in the competitiveness, industrial competitiveness part, what we call the light part of the framework program, or Horizon 2020. And that is roughly 8 billion euro. 4 billion euro for excellence in science and 4 billion euro in the societal challenges. These are the goalposts for information and communication technologies in Horizon 2020. And from these budgets, we finance anything which I will explain later. And so there's more innovation emphasis and more involvement of the industry. And to avoid, I've worked for the European Commission for quite a long time. I can tell you one of the absolute forbidden words is sectoral or sectorial policies, because of the steel experiences of the 50s and 60s. You know that the source of the European Commission communities is in the community of steel and coal. And so it's all about enabling technologies and avoiding sectoral orientation, or as many of my colleagues put it, sectorial, but the word doesn't exist in English. Information and communication technologies, I hope I'm preaching to the convinced here, has an enormous economic footprint. And when we think of many of the projects which we do in all kinds of areas, you can really look around. It's not only in the manufacturing area, it is also in the communication technologies areas, in the microelectronics, in the basic technologies, everywhere. When you really go down what we do there in these research programs and what the results are, then to my estimation it is between 80 and 90% software that comes out of these projects. It shows you that the major impact of it is somewhere in the ICT field. Unfortunately, we're not very successful in increasing the productivity of software development. So it's basically a flat curve with a bit of rationalization. It would be much better if we had a Moore's law on software productivity. Unfortunately, we couldn't produce that. So that is behind that creates 30% of the added value in major EU industries and is a key for addressing many of the societal challenges and creates a lot of jobs. Most of the time that is not seen. I think the layman does not see that these jobs, which are created in small and medium-sized enterprises, which grow anyway faster, are software jobs. Why is Factory of the Future and ICT so essential? We are today very strong in these areas. We have very strong expertise right across many user industries in embedded software and embedded systems. We are undisputed leading in many of these areas like machinery and automation equipment. The point or the fear behind this, if I may say this in a rather negative way, is that because of the dominance of our US competitors in some of the software areas and in some of the device areas, we are of course threatened in these very broad industrial application of innovations, because not everything there is so open and you can easily enter those markets from that side. When you think of all the access you get by setting the operating systems, setting the basic platforms, increasing the productivity of software development, having much larger home markets, and being able to, despite what I said before about the software productivity, there are some examples, especially of major US software developers, where they claim software productivity gains from 10 to 1 in basic big projects. And if you want to know which companies I mean, we can have a bilateral discussion on that. Maybe it's not 10 to 1, but if it is 10 to 3, then it is an enormous progress, and some competition is coming from that side. Manufacturing is a very large industry segment. It's in itself. It gives us the opportunity to rationalize all our processes, and the industry landscape is very widely structured, also in Europe, around a set of large enterprises. Now in Horizon 2020, we of course have thought about what could be the future, and I try to explain this rather complicated picture rather simple. When you think of the last 25 years of introducing computer systems and control systems and process computing and real-time computing into manufacturing, then it's still not completely integrated. And the representation of many of the instances, or as some competitors put it, resources, is in the computer, in the end, a model of the reality. Now, we all, in the end, philosophically, anything we say here or anything we put on a PowerPoint is a model of the reality. But let's not go so far. Let's go to the point where the reality is represented by its real data in the process. And that's what we call the computing continuum. Originally, this is a term which comes from Intel, but I don't care. They didn't claim ownership. So in the engineering world, it is this dream that you can represent whatever process you have, whatever manufacturing process you have, by the data and what has happened and will happen in that process, which is a form of representation in the computer. When you think of these enormous progresses in Moore's law, for instance, by 5 billion or more transistors per square centimeter, you ask yourself, what are we doing with these 5 billion transistors per square centimeter? Of course, we have almost unlimited storage. We have almost unlimited processing power. It's very, very difficult to use it if we parallelize all those processes. But at the end of the day, this gives us the opportunity to handle all that data and to analyze all that data. We see just a glimpse in this discussion about PRISM these days all over our newspapers, what you can do with that. And of course, that is also a societal question to be discussed. But what we see here is a representation in computers which gives us a fairly good picture of the reality and gives us also the opportunity to plan future processes in there. And this is, of course, built by different computer architectures. Just some are mentioned here, like cloud server farms, embedded computing, high-performance computing. And all these worlds are converging from the engineering world into the managerial services, into the physical world. And I think that is the next step, that is our vision of what is happening there in manufacturing. If we are doing that, we have to think about all the consequences, not only the societal, but also the economic. I have a lot of understanding for you to have a nice coffee. So many of these terms, which are, for instance, here on the converging worlds, when you think of systems or real-time dependable systems, they have been around in research for a long time. But we have now the tools, and as we know in the manufacturing world, we are relatively conservative. We cannot every 5 years or every 3 years change the basis of our computing. But I have a very negative example in an industry I've previously been responsible for. If you have a major industry like the communication technologies industry, and basically the electronic engineers who have programmed networks before overlooked the progress in the software and in the computer science area. And the result was that Cisco took 30% of that market. The result of, if that happens in an industry, at least from my hometown, very industrial, where every company is owned by an individual, that's a disaster. You're more or less banned from the society if that happens to you, that somebody takes 30% of your market. We see today a big decline in the communication technologies companies in Europe. I don't need to mention them, but one of them, for instance, had in 2003 225,000 employees and has today less than 70,000, one major European player. And the question is to be asked, what has happened there? And what has happened there is that the computer scientists took over where previously the electronic engineers were making cables. So the whole thing went into a totally other layer of abstraction. And we can, with all those enablers of ICT, expect that something like that will happen in our field as well. So let's be prepared. Let's find out where are these new concepts. By the way, it's also a personal defeat for me, this success of Cisco. If I ever, in those early days of the internet in 1990, 1991, I ran around and looked for high-performance computing applications, and we had all the very performant boards and parallel boards in front of us, but nobody came with the idea of handling some tables for Cisco routers. Unfortunately, we could have easily built a competitor to that, but we didn't. So the physical world means the internet world. That is, in one sentence, what I tried to say in the previous slide. And we will have a new balance in terms of the 4 dimensions of manufacturing. I mean, I used to learn at university capital, energy, labor, but of course there is the 4th one, knowledge and the ability to program all of that. And cyber-physical systems are expected to lead to a 13% productivity increase. So our vision is also that this is the right moment. At this moment it is a good moment to make new architectures and try a new approach in that. And we think that the visual, virtual, and physical dimensions are the right key for success. Further to the vision, in the cyber-physical systems, we distinguish, and that is, I don't know if it is conservative or not, between the digital, the managerial, and the physical. You can also, in your brain, put behind it control. Now, with all the loopholes that has, there are, for instance, as I am here in an environment which is half Germanophone, try to translate the word control, and you will find that in German there are at least 5 or 6 translations for it. Maybe part of the success when it comes to control units in Switzerland is also because you have 5 different words for it. So there are many concepts behind this. So there is clearly also the concept between distinguishing between the managerial and the physical control. And then you come to these kind of challenges. The data-centric, or now very fashionable, big data and cloud computing challenge. So then the value creating from network operations, that is a new form of organization. And we can see, and what I said earlier, that somewhat the internet needs the embedded systems, but you can also say we need a solution for the real-time aspects of the internet. What we have there today is not really real-time in the sense of an engineer who controls a machine, but I expect that some of this research, which is now going on for some years, will deliver solutions there. In what form, I'm not a prophet, but there will be solutions, that I'm pretty sure. Around that is this societal aspect of more personalized, diversified, and mass-produced products. And let me make there one point I would very much like to make at this moment on the background of all our discussions towards our Asian competitors. We have in Europe many industries which are not mass producers, but which survived the last 30 years. Now when I learned whatever the 3 factors of manufacturing, there was another slogan, which they hammered into my head, which was, you need economies of scale, or you need numbers. You need very high production numbers. That was Stückzahlen in German. That was hammered in our head as students. But today I would, under the influence of ICT, it is mainly a question of how adapted our planning is. You can make successfully cars in relatively small numbers, while the ideology 20 years ago was anybody who has less than 3 million units cannot compete on the world market. But when you look who are the two most profitable car manufacturers at the moment in Europe, then it is really amazing. On the one hand side Porsche, and on the other side Dacia. So these are really two very extreme things. So for me, to adapt that under the influence of ICT research, it seems to be a question of how you organize it and how exact is your prediction of what you can sell and what you can produce. And that is, of course, exactly the theme which is behind this kind of research. So it doesn't need to be always the absolute biggest, largest mass market. I find that we are sometimes in Europe a bit too pessimistic of what we can do. You can also put my whole argument in the word of flexibility. Factories of the futures in Horizon 2020, of course, we are planning now for the first work program in the next year and under Horizon 2020, and we will come out very soon with publications of it. If I see the plans right, we want, after the summer pause in our ICT conference in Vilnius, to have it all on the table and go public with it. We have done that in previous framework programs without decisions, without really having a mandate, without really having a budget. Then they were all staff working papers, but okay, we just push ahead whatever the political decision-making process is as fast as we can, because we know we need to be faster. You said also that one of our biggest problems is that we are too slow. You said it about Switzerland. I took it immediately on us as well, no problem. Now, there is a huge debate, very much to my surprise, on reindustrialization and manufacturing jobs. I have been in the Commission for many years, been very, very criticized and put almost in a corner when I said manufacturing. So for me, it is quite amusing to see how much reindustrialization and manufacturing has been now on the lips of everybody. So it is in the nanomaterials program on the one hand side, and I don't want to deny one thing when I'm pushing so much for manufacturing. The ICT part of it is a very important part. But the progress we have seen over the last 20 years has also some other elements. So the materials, for instance, are clearly another element which comes from the non-ICT part. There are many other areas for me. I thank you very much. So then, it's also a question of balance between these programs. The nice thing of manufacturing is that it is non-sectoral. That's why I introduced the theme like I did. Manufacturing is basically right across everything. And if you ask me, I would say that this part of the process innovation, the discussion of innovation, is still very underrepresented in research. And then behind that is this debate where people, and you should be conscious of that, say that manufacturing is not really a research topic. So if you are in the classical physical research of physics of CERN, not far from here, you often hear the argument that putting research money in manufacturing is not really research. We should be cautious and we should fight that. Because I'm convinced that this is not true. It's a very easily to understand it's very easy to understand the motivation behind that argument, but it is an extremely dangerous argument and leads to some imbalances between basic research and societal challenges and the investment in manufacturing research. So there are subdomains to the cross-sectoral enabling manufacturing technologies like ICT, enabling intelligent and high-performance manufacturing and exploiting new materials through manufacturing. We have then tried to map what the EFRA has given as a roadmap for the factories of the future. EFRA is an association representing the factories of the future research, and we tried to come up and see which kind of topics we would really, in the first calls, link into the domains, as they are called in the research and innovation priorities of EFRA. And there are some innovation technologies and enablers here on the right-hand side. So we would do advanced manufacturing processes, mechatronics for advanced manufacturing processes. Those are the technology enablers which EFRA tells, and we would be in the domains 1, 2, 3, 4, 5, not in 6, which is less focused manufacturing. We at the moment are not covering that. That was showing me my time limits, is 2, or was that something else? So our scope is basically in cyber-physical systems, in cloud computing, and in big data. And we hope that we can move from the idea to production in a fraction of time, increasing the variance with maximum productivity. That's the flexibility argument. Connecting systems and machines, and decentralization of manufacturing automation. Now, on the other line, we have more or less tried to put in relation the product development process to the production process, one as a horizontal process, and link all of that forward and backward. And the major argument is, if the vision, which I outlined before, is the right vision, then what we have to do is link all of that by the data streams which come out of the lower parts of the manufacturing processes into the modeling and into the planning processes, into the abstract processes. Now, the result of that is that we have these 3 major lines for manufacturing in the future. So that's the proposed scope for our work program. So on the one hand side, we would like to do big data simulation and tools integration in the advanced computing, the process optimization and control for cyber-physical systems, and the innovation pilots, and I will say more about that later, and small and medium-sized enterprises. But let me make clear what we mean in the first 2 lines. Well, behind that is the idea that if we are really threatened by some of these integrators who come from the device and the software package side into manufacturing, what we then need is some cross-sectoral platforms which rationalize the programming, which help us to produce the solutions in a fraction of a time. And how can we do that? By bringing together the right consortia who have a common interest in, I hesitate to use the word standards, let's say in being pre-normative, in setting the basic platforms on which these programs are developed. And to do that is, and I insist on that point, is a question of timing, of the moment, of the progress of the surrounding technologies, and then you can do that. And then it is also a question of being fast. And in a sense, we have done that in previous framework programs quite successfully. The industry was then at a certain moment driving us more than we were driving the research process. Because the deadlines were no longer the political deadlines or the deadlines of the framework program. The deadlines were, for instance, the gates of the EMO in whatever bus systems for machine tools. That was, so they more or less timed the projects backwards. It was much more a backward timing than a forward timing. It was set, okay, in December 1992, we have to be on the EMO with this product. Therefore, we have exactly 28 months to do a major IP in that area where we agree on all the basic elements. And to do it that way has been extremely successful in the past, especially when you want to be green-minded. But let's not be naive. It costed also some major IPs which were just appeasing those who were in not to deliver. To be totally frank to you, do you understand what I mean? I was the project officer of a very, very successful project on the one hand side, and another one in which they since 25 years produce paper. Paperware of the worst kind. But we were able to limit them into this second project. I can also tell you outside the room the name of the project, and the project is still alive, and still these big companies are paying fees into these projects. So that is what we mean in the first part in advanced computing. The second one is the bottom-up. There where the cyber-physical system hits the machine or hits the manufacturing process or hits whatever cell you have. And the third one is moving what we have into use. Now, about the third one, again, to be really frank here, the third one is always very sexy at the end of a framework program. At the beginning of a new framework program, we suddenly confronted with many, many academics who want these actions to be minimized because it takes money, and it is really a big money spender from the academic research. So one has to defend that innovation part. So what we're trying to do is crossing this famous chasm in innovation, but behind it is this hypothesis of give them customers. So I think also that the US research fabric is much more pragmatic there. The slogan to say, give them customers, is not from me, it is from my US counterparts, which means basically find users who want to implement it and to be the early adopters and helping often small and medium-sized, but also big companies to get that into a first use in a first showcase. Now the extreme example I have there, what we have done in the past is paying the lithography machine into a Taiwanese plant. If that is not industrial policy, I don't know what it is. But the lithography machine was in the research stage, and the feedback from those Taiwanese plants were absolutely vital for the research to finish successfully. So that is the thinking behind it. Now we have such an action on manufacturing. We spent 70 million on it in the last call of Framework Program 7. There are many advantages of it. I don't give you the full gospel, but the interesting bit is that we have more than 50% small and medium-sized enterprises in there, 70% industrial participation in there, and it seems to be that industry likes that kind of program and gives us, as a part of the factory of the future, these three dimensions of benefits. One is you transfer the technologies between suppliers, users, and competence centers. I have a very personal point there. This is only successful if you get the project into the right mixture. If all partners around the table have a vital interest to succeed, then we give direct financial support, of course, and you get access to competences which are well beyond the sector or domain or the region or the member state. So we want to continue that under work program 1415 in Horizon 2020, and we think that this is a very good model for innovation measures because all the parameters, also those parameters which are always asked to us in Parliament, are green in this program, but it is a little bit more complicated to explain than some of the simple SME merits. Conclusion. Now, what we really try to do is combine many different pots and different policies of the European Union in an industrial strategy. And let me say something to illustrate it to you who is probably not so much in these political circles as I am confronted often with. 10 or 8 years ago, I wouldn't even dare in an audience like you to use the word industrial policy without telling you which paragraph in the Treaty on the European Union would cover me. Because there is a mention in the Treaty of the European Union that research should lead to industrial policy or should be an instrument of industrial policy. No way that I would have, you see, it was really dangerous to do, and I had audiences who almost threw bad tomatoes at me when I was doing that, especially in the UK. And I had to insist that the Treaty of the European Union says it, that it is signed by all member states that they want to do it. That is behind this, so we combine the different policies which are there. You see, there are some major construction sites in this, like the EMD loans, like the structural funds, the skills. So all of that, but it moves. Very much to my surprise, this kind of policy forces people to think and start discussing in these areas. And that's a very good sign. So we have some strategies then. We want to cover the full value chain, capitalize on the size of the EU markets and our diverse strengths, so diversity can be turned into an advantage, and we try to align the policies and necessary budgets and resources. And when you think of it, I am almost inclined to quote the German Chancellor who said the other day something like, it is not a question of budget, it is a question of to channel it to the right people. And I can only agree when you see the absolute figures behind the previous policies. It's mind-boggling big. But you ask yourself, why is it not having an effect sometimes? And then you find all kinds of inefficiencies, etc. So we want to make it successful now, align policies and necessary